Hi everyone, welcome to my YouTube channel. On our today's lesson, we're going to see the main concepts of sigma notations and how we are going to denote and define what is sigma notation in general. And then I'll try to show you different examples that are really important to support what's the sigma notation in general. So, if you are a new member of my YouTube channel, don't forget to share, like, and subscribe my YouTube channel, XMR Trading. So, now let's continue. What's sigma notation and how we're going to support, denote, describe, generally, sigma notation in general. So now let's see. So at the very beginning, let me try to explain what is sigma notation. So to define what the sigma notation in general, in order to define what is the sigma notation, first of all, let's consider or let's just take an arbitrary end term for the sequence. Let the end or the general term for the sequence is an. Assume that, or let's assume that, let's assume that an is end term for the sequence. Assume that this is end term of a sequence in general. A sequence. Then the sum of the first. Then the sum of the first n terms of such sequence or the sequence an is given by, it is always given by the sum a1 plus a2 plus dot plus an, that is denoted by an. N is running from 1 to m. I mean, k is running from 1 to n in general. Now look, this is a very important concept of sigma notation. A very important concept, what's a sigma notation. I already assumed an is end term for any sequence, an arbitrary sequence. Then the sum of the first n terms of the sequence, this is an, is generally given by a1 plus a2 plus dot a. That means summing, you know, what is sum in general mean? There are two basic kinds of sums, infinite and finite sum. And whatever the sum in general, the sum of the sequence mean the series of the sequence. So the series of any sequence will be denoted or will be described by this way. This is the general notation what the sequence mean. So the summation of k is running from 1 to n. So now let me explain generally what this means. That means, now let me explain what this notation in general. Let's consider now k is running from 1 to n. You know that this is end term for the sequence. You know that this is end term of the sequence. We don't know the kind of the sequence, but this is a general or end term for an arbitrary sequence as a whole. So if you consider this formula, k mean this k refers to that is index of summation. We call this index of summation. Now we call this is the index of summation. Now k mean the index of summation. And 1, this number, 1 refers to that is first value of n. The first value of n. As is the first value of n mean, in other way, we can recall this as lower limit of summation. As the lower limit of summation. We call this is lower limit of summation. We call this is the lower limit of summation. And finally, this n refers to last last value of n. This is the last value of n. This is the last value of n. N itself refers to the last value for the sequence. Or in other way, now we call this in other way. We call this upper limit of summation. Upper limit of summation. So this is the main concept, what sigma notation, and how it is important to denote or describe the sum of the first any sequence in general. So this is the shorthand representation of the summation of this one. And you know, this Greek symbol, a Greek symbol is known as a sigma notation. We call this is sigma notation. As is simply the sigma notation. This is a Greek letter that refers to what sigma notation. That is in other way, this is the sigma summation. This is the summation notation. In other way, now we call this is summation notation. That is simply the summation notation. That is simply summation notation. So this is all about how we define and describe the general concepts of sigma notation as a whole. So now let's suppose this is a different example. Now let me try to show you how we're going to find the sum of the first any sequence in general. How we are going to find sum of any sequence. Let's see example. Now let's see the first example. Let's find now on the first example, evaluate the following sum. Let us evaluate the following sum. Now the first example, what is the sum of this generally 3 and n is running from 1 to 6? What's the sum of this formula? On the second example, I'm going to show you what is the sum of 6 and n is running from 3 to 8. What's the sum of this formula? And finally, let me show you how to find the sum of 3 into 3. Let's find 3 over n minus 1 over n plus 1. 3 over n plus 1. N is running from 1 to 2n in general. Now look. So how we are going to evaluate, how we are going to find sums of all these examples. I think this is a very simple example. So let me show you how to find the first problem. On the first problem, the summation of 3n, n is running from 1 to 6 mean, since any constant is independent of the summation notation, so this is generally given by 3 times the summation of n is running from 1 to 6. As you see, any constant is independent of summation. So you can take out the constant out of the summation notation, and that is generally given by 3 times of this. So the sum of the first 6 sums of the sequence is very trivial. This is given by 1 plus 2 plus 3 plus 4 plus 5 plus 6. That means, look, when n is 1, it is 1. When n is 2, it is 2. When n is 3, it is 3. When n is 4, it is 4. When n is 5, it is 5. When n is 6, that's 6. That's very simple. So this is exactly 3 into. Now this is 6 plus 4, 10, 15, 21. So this is exactly given by 63. So this is the result. You see how we are going to determine the sum of such a problem? I think this is very trivial example to show what is sigma notation in general. So this is the shorthand representation that refers to what summation in general means. So now we can find the summation of this problem, this one. And B, let's see B. B mean, what is the summation of 6 where n is running from 3 to 8? How we are going to find the result of this formula? So in order to find the sum of this formula, how many number of terms will be added on this example? And from where n is running n is running from 3 to 8. So from 3 to 8, we have 6 different terms of the sequence. That means this is generally given by. Now let's say this remark. It's very important remark. Now the remark takes this remark. The summation of any constant. If k is running from 1 to n, this is generally given by. Let's assume that k is running from m to n. Let's assume the summation of any constancy where k is running from m to n. This is always given by n minus m plus 1 times c. So this is the sum in general. N minus m plus 1 times this constant will be the summation. So because of this principle, this is exactly given by. It's exactly given by 8 minus 3 plus 1 times 6, which is exactly 8 minus 3 is 5. 5 plus 1 is 6. 6 times 6 will be 36. That's very trivial. Or we can show how we are going to find the sum of this one. This is a very simple or very tricky method of finding sum of such a problem in general. So this is the solution for such a problem. And now let's come back to a third example. The last example of this sigma notation. On C. C means what is the summation of 3 over n minus 1, 3 over n plus 1. N is running from 1 to 20. So generally, it's a very important example to show how to find the finite sum of the sequence. So generally, this is a finite sum. How we are going to determine the finite sum of this problem? So in order to determine the finite sum of this problem, first of all, you have to know how we're going to represent or denote this problem. So this is generally given by the summation of 3 into 1 over n minus 1 over n plus 1. N is running from 1 to 20. And as I told you before, since a constant is independent of the sigma notation, it is always given by 3 times summation of 1 over n minus 1 over n plus 1. N is running from 1 to 20. So now look, as you see on this example, you have already this one. We have this. That means for this example, let's assume that an for the sequence. The general term for the sequence is 1 over n minus 1 over n plus 1. Now mind you, what is the result? If n is 1, we have a 1. Directly replace 1 in place of n, and this is exactly 1 minus 1 over 2. If n is exactly 2, this will be a2, and that is given by 1 over 2 minus 1 over 3. You can directly replace 2 on this. 1 over 2 plus 1 over 3. When n is exactly 3, so this is exactly a3, 1 over 3 minus 1 over 4. When n is exactly 4, this result a4, which is equal to 1 over 4 minus 1 over 5. And hence, this is generally given by, this is given by 3 times the summation of a1 plus a2 plus plus a20. That these two algebraic problems are equivalent. They're equivalent. These and these are equivalent. So in place of a1, you have to replace this one. In place of a2, you have to replace this one. In place of a3, this one. In place of a, this one. Finally, let me put what is a20. A20 means 1 over 20 minus 1 over 21. Is that? A20 means this one. This n exactly 20. Similarly, n exactly 19. That is a19, which is equal to 1 over 19 minus 1 over 20. So this is the sum. So generally this is given by, it is always given by 3 into, this is given by, what's the first sum? 1 minus 1 over 2. 1 minus 1 over 2 plus What's the second sum? 1 over 2 minus 1 over 3. 1 over 2 minus 1 over 3. Plus 1 over 3 minus 1 over 4. Plus dot plus this mean and 90 mean 1 over 19 minus 1 over 20 plus 1 over 20 minus 1 over 21. So we have this. Now look how we are going to determine this sum. So the sum of this formula mean this implies that the summation of 3 times 1 over n minus 1 over n plus 1, n is running from 1 to 20, is generally given by 3 into. Now look, as you see on this example, this is cancelled by this one because this is negative, this is positive. It's also cancelled by this one. And 1 over 4 is also cancelled by another value. 1 over 20 is also cancelled by its negative. Because negative 1 over 20 plus 1 over 20 is 0. So what's left? The first and the last. So this is exactly given by 1 minus 1 over 21, which is given by 3 into 21 minus 1 over 21. That is exactly 3 into 20 over 21, which is already 16 over 21. Is the solution. You see? So in generally, if we have such a problem, you can take this up as a remark. The summation of 1 over n, let's assume that that's 1 over k minus 1 over k plus 1. K is running from 1 to n. How we are going to find the summation of this in general? That means for any arbitrary constant k and n, how we are going to determine the summation of such a problem. This is a typical example of telescopic series or sequence. So in order to find the finite sum of any telescopic series or sequence, that is always given by n over n plus 1 is the solution. This is the upper limit of summation. That means for any particular example of a telescopic series, the finite sum of any telescopic series mean n means the upper limit of summation. The upper limit of summation over 1 plus the upper limit of summation. This is the result in general. So the finite sum of this problem, n over n plus 1. As you see, what is the sum of this one? So generally, this is in general given by the summation of in general 1 over n minus 1 over n plus 1. N is running from 1 to 90. This is exactly 19 over what? 90 plus 1 is the solution. So this is exactly 90 over 91. Is that? This is how we are going to determine solution of this problem as simple as possible. So this is all about our today's lesson. If you have any questions, any doubt regarding to this one, and if you have any other problems related to mathematics, you are welcome. You can put your question, any possible question and comment under the comment. So this is all about our today's lesson. Thank you for today. Bye bye.